Hi everyone, welcome to today's class. And in the previous video, I'll be treating portfolio theory. And I said that we're going to look at a question for us to practicalize all I've been talking about under portfolio theory, all the theoretical aspects. So today, I'm going to look at this question for us to use to solve, to practicalize the theoretical aspect in which we have talked about so far on portfolio theory. So looking at this question now, use this question to solve for return, expected return, variance, standard deviation, and we also look at correlation coefficient, covariance, using this particular question. So the question goes thus: Rogers has just won 100,000 naira from Lucky Lottery Limited and has decided in the interim to place the money on two securities, A and B, for a period of 1 year. 60,000 naira is to be placed on security A and the balance on security B. The estimated return that is Rogers estimated returns, that is cash flow to be received at the end of the year plus project value at that time. And probability of the three possible states are as follows. So we have states, we have probability, we have projected return at the end of the year. So the projected return at the end of the year, we have for security A or security B. So these are the probabilities attached, and these are the states for each of these securities. Now, the question now goes further and says what? Calculate the expected return, variance, and standard deviation of each security. You should calculate the expected return, variance, and standard deviation of each security. So therefore, now when I treated return on shares or shares return in portfolio theory, which you have the videos in this YouTube channel, you can just go through the videos where we have shares return. Go through the videos and spot the area where I have what shares return. There's one thing I made mention then. The formula I gave them was that how do you calculate the return on the share? So the formula I gave them was return R is equal to dividend D1 plus P1 minus P0, close the bracket, over P0. Where D1 is is dividend received during the period. While P1 is the value of the shares at the end of the period. While P0 is is the purchase price of the shares all over P0. What's about to compute this, divided by this, and add it to this. So this will be the return on the shares at the end of the period. Simply put, the return on shares comprised of two things, which are what? Dividend and and capital appreciation. So in this question now, we can see that we have return at the end of the year. These are the return at the end of the year for each of these possible states. And these are the probability attached to it. So these are the level of confidence, these are the probability attached to this possible state of returns. So if that is the case, we are asked to do what? To calculate the expected return. So from it now, we are need to do what? To calculate the return from each of these projects using this formula. So now the question is there dividend paid at the beginning of the period? there's no dividend paid at the beginning of the period. According to this question, we don't have any dividend paid at the beginning of the period, according to this question. So, but we have what? So, we don't have it, so we don't need to use it. So, we have P1. P1 is what? Price at the end of the period, all of the shares at the end of the period. So, created return at the end of the year. So, we have for each of these 75, 73, 67, on and on like that. And for B, for security B, we have as well like that. So if that is the case, we need to calculate for security A, for security B in order to get our return. So it's the return that we are going to use in the long run to do what to solve for our expected return. So therefore, let's now start. So we're going to use this formula to do what? To compute our return. Use this formula to compute our return. So for security A, except for what? For each of the securities. Security or security. So for security A, for stage 1, so security A now, we have stage 1. Stage 1. So P1, what is P1 there? That is 75,000. Minus P0. So what is the purchase price? I will give you the purchase price there. Rogers has just 100,000 from Lottery Limited and has decided in the interim to place the money on 2 securities, A and B, for a period of 1 year. 60,000 is to be placed on security A. That is to say, the purchase price for security A is what? Is 60,000 naira. So 60,000. All over 60,000. So for stage 2, we have 73,200 and 60,000. Because that's what we invested. All over 60,000. Stage 3. So we have 67,200 and 60,000. All over 60,000. So what do we have? Let's compute it and see what we are going to have at the end of the day. So let's see. So 75,000 minus 60,000. Okay, divided by 60,000. So here we have 25%. So 73,200 minus 60,000 is equal to divided by 60,000. We have 22% here. 67,200 minus 60,000 divided by 60,000. We have 12%. Okay, so this is return from each of what? From each of each state here. We have computed the return for each state here. Let's go ahead and the question asks us to compute what expected return. So, and mark you, this is our return from each state. What will now be our expected return? So our expected return, why is it that we have a particular return and we are still looking for expected return? That is what we call what? That is what I explain under what? Risk. Risk is what will not make you to be able to achieve this return. And to incorporate this, that is what you are now doing what? You are not putting out the effect of what? Of probability. That what? We may not likely receive this return at the end of the day because of what? Because of what risk that is incorporated in what? That because of risk. So therefore, we now attach a kind of what probability to this return. So from there, we're able to have what our expected return. So for security A, let's now compute for security A. This is what is so expected return. So don't forget, we need to title it. So Rogers, that is the name of the person. So computation of what? Calculation of expected return. So calculation of expected return. Expected returns, variance, and standard deviation. Going to short it, write it in full, try to hand your full mark, and standard deviation. So, okay, so these are to start to answer questions. So you start by the name, computation, who knows what you are computing for. So let's now start. So state your state. State 1, we have state 1, state 2, we have state 3. So what is the probability? The probability given in the question, we have 0.3, 0.30, 0.45, and we have 0.25. So after that, let's have our return. This return that we have computed, return. So let's do it for security A, return. For state 1, what do we have? We have 25%, that's 25. This is absolute value. 25, 22. We have what? 12. So after that, we have our return, expected return, which we normally call what? A bar. We denote expected return by A bar, which is the function of what? P times A, which is what? P times A. What is P times A? P, probability times this. So what is it? 0.3 times 25. Let's solve for it. Point 3 times 25. You have 7.5. So 0.45 times 22. 9.9. So 0.25 times 12. We have 3. So we sum it up. So 7.5 plus 9.9 plus 3. We have 20.4. This is our expected return. This is our expected return. This is the expected return. So this is our expected return. So the question goes further to ask us to do what? To calculate our variance. To calculate our variance, and in computing our variance, we need to have another table which we have what? A minus A bar. A minus A bar. So at the end of the day, we have what? Another table there. Okay, let's compute our A minus A bar first. This A minus what? A bar. This is now our A bar now. A, this minus this, that's what I'm talking about, A minus A bar. So we now have it to be 25 minus 20.4. So 4.6. 22 minus 20.4, 1.6. So 12 minus 20.4 minus, that is what? Minus 8.4. So we have another row column here. So now we want P, A minus A bar. We close it. So we look for that. So A minus A bar, we square it. So we have it like this. So we square it, we have A minus A bar in that form. So what are we talking about here? We said we want to multiply this. This A minus A bar is what we have here. So you square this and multiply it by the probability. So 4.6 times 4.6 is equal to times the probability, 0.3. You have what? 6.348. So 1.6 times 1.6 times 0.45, 1.152. So minus times minus 8.4. So you square it, what do you have? So 8.4 times 8.4. So multiply by the probability, 0.25. We have 17.64. So you sum it up. Sum it up. So 6.348 plus 1.152 plus 17.64. We have 25.14. So 25.14. So 25.14, this is our variance. So this is variance now. That is variance. And what is what? Standard deviation. You have solved for return, expected return, you have solved for variance in standard deviation. So our standard deviation formula is what? So standard deviation, SD, standard deviation. Which you might denote as what? This is what is the square root of variance. This is what? Square root of variance. Which is what? 25.14. So what is 25.14? 25.14. So we have it to be 5.01. 5.01 here is our standard deviation. So 5.01 is our standard deviation here. So what do you mean by standard deviation? Standard deviation is risk. Standard deviation is what? Is risk. Is the risk of this security. So what are we comparing now? You now look at this security, look at the expected return from this security 20.4, and look at the standard deviation 5.01. And this is the risk attached to this return. That is, you're going to have what to, if you're having this what, this, if you're going to accept this return, you must be able to do what to accept this risk as well. That is, this is the risk attached to what, to this return. So this is what we have appraised what project A here now. Project A has been appraised in this form now. So therefore, we are still going to need this value here, and this value here, and this value here. So this is what to expected return. This is how to calculate expected return, most especially for projects having what value at the end of the project. At the end of the period, we have what particular value at the end of the period, and we have purchase price at the beginning. So in such a scenario, you have to follow this method, use this method to calculate your return. And before you, this is the return which you have computed here. Before you now proceed to do what to calculate your expected return. So this is our expected return here. A bar, we as A bar is equal to P times A. P times A. We have the expected return. So you move forward to do what? Move a step further to calculate this and have the variance. And the square root of variance is what is your standard deviation. So that is for security A. That is for security A. So let's look at security B, as I've said, as the question asks us to do it. So this for security A. Now, I'm going to rub this now. So let's now look for security B. Security B, we still have the same probability. So let this go. This we have to go. Okay. Now for security B. For security B, we also have P1. What is our P1 for state? So for state 1, we have it to be 45, 600, minus how much was invested? 40,000. Let's say 60,000 is to be placed on security and the balance on security. So this is the balance, which is 40,000. So all over 40,000. So for stage 2 is what? 47,200 minus 40,000. I'm still using this formula, all over 40,000. So for stage 3, 48,000 minus 40,000, all over 40,000. So what do you have? So what do you have here? So what do we have? 45,600 minus 40,000 divided by 40,000. That is 14%. So 47,200 minus 40,000 is this divided by 40,000. We have 18. So 48,000 minus 40,000 divided by 40,000. That is 20%. Okay, so we have that now. So we have that. So this return, we are bringing them down here, 14, 18, 20. So probability, so this one is B now, B. So this is B, for project B, B bar B. So this is B, B minus B bar, so B minus B bar. Okay, because we are solving for project B now. So let's move. So this by this. So 0.3 times 14. What do we have? 4.2. 4.2. So 18 multiplied by 0.45. We have 8.1. 8.1. 0.25 multiplied by 20. That's 5. That's 5. So we sum it up. 4.2 plus 8.1 plus 5. 17.3. So these are expected return. Expected return. Expected return. So let's calculate our variance now. Our variance now be what? We cannot come to this before without passing through this stage. So our variance is B, this B minus B bar. So 14 minus 17.3. So negative, that is minus 3.3. You have a negative. So 18 minus 17.3. What do you have? 0.7. 0.7. So 20 minus 17.3. You have 2.7. 2.7. Okay, so you square this, multiply by the probability, you have your what? You have to have your variance. So you have that value there, variance. So 3.3 raised to power 2 times 3.3 multiplied by 0.3. We have 3.267. So 0.7 multiplied by 0.7 multiplied by 0.45. We have 0.2205. Okay, let's make it 3 decimal places, 3 decimal points. So 221. Now to make it uniform. So 2.7 multiplied by 2.7 multiplied by 0.25. We have what? 1.8223. Okay, so these are variance. Let's sum it up. Okay, so 3.267 plus 0.221 plus 1.823 is equal to 5.311. So by that, our standard deviation now will be standard deviation, which is denoted as this, is equal to the root of what? Of the variance, 5.33, 5.311. 5.311. So which is what? That is what? 2.304. 2.304. Okay, so 2.304. So having said this, if you now compare the return to the risk, in this for security B, you see we have a return of 17.3 and the risk of what? 2.304. So if you now compare this to portfolio to investment A, there we have 20.5 or thereabout and what? 5.001 for the standard deviation. It tends to do what? If it is you want to choose between these two investments. You consider what? The return and the risk. So we have for security here we have a return of what? 20.5 or thereabout, and we have what? Return of what? 17.3 for security B here. So it tends to do what? To measure the relationship that is between what? The risk and and the return from both securities. So in this portfolio, in this combination, this is what we are expected to do, or to compute. So from there, we're able to do what? To make analysis and and decide whether this portfolio is an efficient portfolio. So considering the risk and and return to that to that effect. So here you are able to do what? To compute the standard deviation, expected return, variance, and standard deviation of the two securities. So we can then proceed. Let's now move forward to compute to practicalize other aspects of what we have learned so far. Here we also talked about. So let me see other questions. Okay. Let me look for the question portfolio. Okay, so now we are going to solve this now. So let's look at another requirement which we need to do to solve for covariance and correction coefficients. So we are done with requirement A. Let's say B, requirement B. B says what? Calculate the covariance between the two securities and correlation coefficients. Correlation coefficients. Okay. Now, covariance. Remember the formula I gave for covariance? Covariance formula is covariance. The formula for covariance formula is, I gave the formula for covariance as P A minus A bar what B minus B bar. So you sum it up, you can put forward to is what? Summation of this, okay? At the end of the day, you sum it up. So you bring what? A bar under our security A. We computed something like this. So we said, before we now go ahead to compute our covariance, we computed what? A minus A bar, and for security BB minus B bar. So let's now bring down those computations we have for them under it then. So just flash back and see. So still have your state. So for covariance now, state, still have to do your state. Probability, we still need the probability. So we need what? A minus A bar. We need that. We also need what to B minus B bar. So the states, we have state 1, state 2, state 3. So the probability, they share the same probability. So 0.30, so 0.45, so 0.25. So what do we have under A minus A bar? In what we just solved, what we solved? What do we have for that? So after that, we now have this P. So A minus A bar, B minus B bar. So for A minus A bar, in state 1, under state 1, what we have there was, we have 4.6. I can see how we just make reference to your own, 4.6. We also have 1.6, 1.6, yes. For stage 3, we have minus 8.4. Yes, we have minus 8.4, minus 8.4. We have for stage 3 under security A. So, but for security B, we have the first one, we have minus 3.3 for B. So we have 0.7 and 2.7, 0.7 and 2.7. So what by this, what are we talking about here? It means P is the probability, this is this, this is this. So this multiplied by this, we have it here. So you have it. So let's do that. Let's quickly solve for that. Let's quickly solve for it. Let's use our calculator. 2.3 multiplied by 4.6 multiplied by 3.3 minus 3.3. So we have minus 4.554 minus 4.554. So 0.45 multiplied by 1.6 multiplied by 0.7. So we have 0.504. Okay, so 0.25 multiplied by minus 8.4 multiplied by 2.7. We have what? So 5.6 minus 5.67. You have minus 5.67. So you sum it up. So let's look at the total. So 4 minus 4.554 plus 0.504 plus minus 5.67. 5.67. So we have equivariance of 4.554 plus 0.504 minus 4.554 minus 5.67. So we have minus 9.72. Yes, when you sum it together, when you sum it up, we have that value, we have that figure. So that is our covariance. So that is our covariance. So these are covariance. So that's our covariance. So we're not talking about correlation coefficients. Correlation. So what do you mean by covariance? Covariance simply means how does what two securities move together? How do they co-move or how do they co-vary? So we want to measure how they move. Is there any positive correlation between them? Is there any negative correlation between them? Is there no correlation at all between them? So you can see now, the covariance, you can see we have a negative covariance. It means what? There's what? Negative correlation between these two securities. You can see that there's negative correlation between what? These two, negative covariance between these two securities. That is, they are not moving in the same direction. One is moving towards one side, another is moving towards the other side. So, and for us, if you have computed the covariance, which has what? A negative covariance, definitely the operation coefficient definitely will also be negative. A positive covariance is going to give you a positive correlation coefficient, while a negative covariance will also give you what? A negative correlation coefficient. So let's look at it. Let's practicalize it and see. Let's practicalize it. So correlation coefficient. So what is the formula I gave for correlation coefficient? So I said is what? Covariance of A and B. Covariance of A and B over standard deviation of A and B. Standard deviation of A times standard deviation of B. So standard deviation, STD, standard deviation of A multiplied by standard deviation of B. That is the formula for correlation coefficient. So let me see if you can still see the work from there. Okay, let me have my correlation coefficients here. Okay, let me have my correlation coefficients here. Since the cannot color is there. So correlation coefficient is equal to covariance of A and B over standard deviation of A times standard deviation of B, which is what? Minus 9.72 all over. So what is the standard deviation of A that we computed the other time? Standard deviation of A that we computed, I think the risk for A computed it to be 5.01 multiplied by, what is standard deviation for what? For security B? 2.3, see 2.311, yes. Remember 2.311. So 2.311. So 2.311. So let's do the calculation and let's see. So by this 5.01 multiplied by 2.311, so we have 11.587. 58711. So 9.7 divided by 11.57811. So we have what? 8.4 minus 8.4 is equal to minus 8.4. Minus 0.84 minus 0.84 minus 0.84 rather. Minus 0.84. So minus 0.84. Minus 0.84. That is our correlation coefficient. That is our correlation coefficient. So correlation coefficient tends to do what? To measure the degree of what? To the degree of risk. It tends to do what? To measure the degree of risk that is in a portfolio. So we can see now that the risk is not even up to 1 in this case. The risk, you can see that what? So the correlation coefficient is not up to 1, meaning that the risk of the two securities in the portfolio is not up to 1, which is a very good portfolio. So having said that, so that is how to do what? How to calculate the covariance and correlation coefficient of two securities. So as a portfolio, let's quickly look at what the return as a portfolio. Now we have been computing the return as individual securities. So let's now look at it as a portfolio. Let's now look at the return as a portfolio. What we have been doing now, you have been examining what the return on these securities individually. Let's now look at it together as what? As a portfolio. So let's now say we come and see what are the return of his portfolio. What are the returns of of his portfolio for each of the possible states. For each of the possible states. Now, what I've been doing so far is what? Is the return, the standard deviation and the covariance as what to our variance as individual security. But now let's now look at it as a portfolio. So state 1, so we have our probability, we have the return as a portfolio. So the return, let's symbolize the portfolio with M. The return. So we now have what we call the expected return. So let's call that what? M bar, which is what? M times P, P times M. So we have it like that. So it's actually we ask you to calculate return now. So if that is the case, let's have the states, state 1, state 2, state 3. The probability still remains the same, 0.3, 0.45, 0.25. Now, we want to combine the securities, we want to combine the securities into one as a portfolio. We want to see it as a portfolio now. We want to see it as a portfolio. Now, we have two securities, securities A and security B. We want to combine the two now. So, that is, for each state, we have return for each of the states, for security A and security B. So, for security A, we have 60% was invested in security A, 60%, multiply what is the return in state 1 for security A. So, we have for security A now. The return in state 1 for security A, the return in state 1 for security A is 25. So 25, so we still have the same amount invested, 60 over 100, times what is the return for security A in state 2 is 22. So the same thing applies, 60 over 100, 60 is what percentage increase, the percentage you invested in security A. Multiplied by what is the return for security A and state 3. That is 12. So plus 40% of the value, of total value, multiply what is the return for security B in state 1. The return is 14. 14. So 40% plus 40%. Multiply. What is the return that we computed for security B in state 2? Is 18. 18. So plus 40 over 100 times what is the return for state 3? It's 20. So by this we have combined the two securities into one portfolio. Let's now sum it up. So when you do your computations, you compute this, that is 0.6 times 25 times 25, also 0.4 times what? Times 14. So when you compute it, you have the solution as follows. You have it as follows. You have it as 20.6, 20.6, 20.6, so you have the 20.6, press your calculator, 20.6, you have 20.4, 20.4, 20.4, 20.4, and you have 15.2, 15.2. So by that, this is what you are going to use to do to get your expected return for the portfolio. Expected return of the portfolio now. So now be what? 0.3 times 20.6. That is 6.18. 6.18.45 multiplied by 20.4, you have it to be 9.18.25 multiplied by 15.2, 3.8. So let's sum it up to have our expected return. 6.18 plus 9.18 plus 3.8, that is 19.6. 19.16. So 19.16. So we can also move further to do what to compute our variance. So by saying what? N minus n bar, n minus n bar. So P m minus n bar. P m minus n bar squared. So let's now date m minus n bar. This is our m now minus this. So 20.6 minus 19.16. So 1.44. So 20.4 minus 19.16. 1.24. 15.2 minus 19.16. So that is minus 3.96. So square it. 1.44 multiplied by 1.44 multiplied by the probability 0.3. We have 0.62208. Without everything. 0.45 multiplied by 1.24 times 1.24 times 0.45. 0.69192. 3.96 times 3.96 multiplied by 0.25. So we have 3.9204. Let's now sum it up. We have our variance. By that we have our variance. So you have it to be 5.2344. These are variance. So if that is our variance, so let's now compute our standard deviation. P is square root of variance. Standard deviation is equal to the square root of variance, which is what? 5.2344. So what is it? 5.2344. 2 point is equal to 2.287. So that is our standard deviation for the portfolio. These are return for the portfolio, and these are standard deviation for the portfolio. It's a very good one. It's a very good one. So that is how to compute the return for what? For a portfolio. So that is how to compute the return for a portfolio. So let's now move further. Let me get another marker here. So that is one method of calculating the return on a security, on a portfolio. We also have another method of calculating the return on a portfolio. So, as you can see how we have done the computations here. Very simple. So D now said D, becoming D. D said was using the general formula. General formula for the mean return and variance of two securities two security portfolio we compute the mean return, variance, and standard deviation, and standard of his portfolio. Okay. So we should use the general formula. Doing the formula method. So the formula method for calculating mean, the formula method for calculating mean is what? Is weight of A times return on A plus weight on B multiplied by return on what? Return on B, especially return on B. Now, using this formula, we should be able to do what? To arrive at the same answer we should do what? We arrive at in the previous, when we use the tabular approach, the other formula. So now what is weight of A? Weight of A is what? 60. 60 by 100. And this is the percentage we invested in A, multiplied by the